we're still testing, so we may have you say something else.
So just leave this up here.
Okay.
Trying to find out where it's gonna.
Yeah. There are speakers in the ceiling. See, it should be coming out through that, so it should be
Right.
all the way. Yeah.
Okay.
Sorry.
Well, we got the right guy working on it.
This is what happens when you try to do something high tech here.
People are gonna be disappointed that you can't record it.
Second. I got to take care of something on my screen, and we'll be right back. Okay. All right, so I'm going to just do a little introduction. My name's Steve Kissel. I'm here representing the Cochise Groundwater Stewards, and we're honored today to have Kristine Uhlman speak with us. I'll introduce her in a second. I want to just go through a few meeting etiquette things here. Okay. First of all, I wanted to say the meeting today was organized by two groups, the Cochise Groundwater Stewards, and both of these groups are community-based grassroots groups that are trying to help protect our beautiful valley here. Cochise Groundwater Stewards has primarily been focused on groundwater protection over the last couple of years. I should be on the microphone. Sorry. Cochise Groundwater Stewards has been working to protect our groundwater here for the last couple of years. People for the Playa is a relatively new group. Joanna Seelig takes most of the credit for getting them organized. Joanna, raise your hand. She's in the back of the room back there. Joanna, and this came up in response to some information that a lot of you saw on the internet about the lithium exploration wells that were going on in the Playa. So, and their role is to help protect the Playa and monitor what's going on with the mining operation, potential mining operation, and make sure we're ahead of that particular risk. And I also want to thank VTC for this beautiful room and letting us use it. It's great to have this. And we really wanted to have a meeting. We've had other meetings down towards the southern end of the basin. We really wanted to have something here in Willcox, and this is a great resource. So despite the little bit of glitches here, we really are appreciative of that. Okay, let's just talk a couple minutes about meeting setup and etiquette. For those of you on the phone, we're going to ask, online, we're going to ask everybody to stay on mute. And then also recognize in the room, if you say something, people up here are not going to be able to hear you, potentially, unless you have the microphone. What we're going to ask you to do, and there are 3x5 cards. Joanna, do you have a 3x5 card? Yeah. We should probably just put some around each table. And if you have and if you do have them, or if you have another piece, you can write on another piece of paper. As questions come up, write them down, and we'll collect them. Raise your hand if you have a question. We'll collect them, and we'll go over all those questions towards the end. As things come up in the presentation, we may address some of your questions. So we'll ask you. We won't go through the individual questions till the end. But I will serve as the moderator, and I will probably ask Kristine questions, particularly if I see some confused faces in the room, or if an issue comes up that I think is particularly pertinent to maybe elaborate on. And for those online, you'll be putting your questions in the chat area of the function, and we've got a couple folks monitoring the chat, and they will be I'll give them the microphone, and they will read your questions. So hopefully it makes sense. Any questions? Everybody good with that process? And everybody can still hear good. Somebody's not on mute because I'm hearing background noise online. So please put yourself on mute. Thank you. Okay, with that, I'm going to introduce Kristine Uhlman. This is a real pleasure. Kristine I met Kristine about 2 years ago down in Douglas at a presentation she did on the hydrology of the Sulphur Springs Valley. And ever since then, she's been a wonderful resource. She's so generous with sharing her information, her knowledge, and her time with us to help us understand better how hydrology works in this area, how the geology affects things. And so when this issue of the lithium mining came up here, what better person to ask? And it turns out she actually has a direct connection with lithium exploration. Also, she's particularly well versed in this. So it's going to be a real pleasure for us to hear her today and what she has to say about that. But Kristine is a semi-retired. I say semi-retired because she does help folks like us, but she also does other work on the side still, and she's still in fairly good demand for being semi-retired. But 45 years of experience. She's laughing right here. And her work is really focused on arid land, subsurface exploration. That means underground exploration, both for minerals and for also looking at what we call aquifer characterization. That's basically, let's figure out what's going on underground with that water that we all depend on. And that's her area of specialty. She's a former board member of the National Groundwater Association, which is a really cool organization that does a lot of work to protect both the quantity and safety, water quality of our of groundwater around the country. And actually, I think they have international members. And in addition, she's very well versed in construction of wells and how wells work. And she's co-authored this book here, some of you can see this, called The Well Owner's Guide to Water Supply. And this is published by the University of Arizona Cooperative Extension. I happen to have 4 or 5 extra copies up here for those of you who are well owners and would like a copy. We'd be happy to give them out to you. So after the meeting, come up to me if you're interested. With that, I think we're ready to sell. Oh, in addition, I just want to mention, we have some copies of a story, a publication that was published by Texas A&M. And this was written by Kristine for Texas A&M, this publication. We've got some extra copies here. We can pass those around for those interested, but provides a lot of good background on lithium. It's a good little resource, so we'll make sure you have those. Joanna, you want to just take those and put them in the back? People can...
Steve?
Yes?
We'll make the slides available after the presentation.
Oh, yes, thank you for mine. Yes, and we will send out, if you signed up on the contact list or already on our contact list for Cochise Groundwater Stewards or for people for the Playa, we will send out the slide deck to all of you afterwards. We'll just send it out. If you're interested, keep it. If not, you can delete it. So, all right. Any other last minute? Bathrooms are in the back, straight back. Men's on this side, women's on this side. Thank you. Okay. With that, Kristine, I'm going to let you introduce yourself, or say, so they can actually see you instead of the presentation. And go ahead.
Howdy. Are you seeing me or are you seeing you?
Hold on. It's some reason. Yeah, they should be seeing you. How can I get you?
She's on my screen.
She's on your screen, but they can't see you in the room. Okay. Oh, no. Oh, Lordy.
Well, let's start with the slides. I don't think.
Yes, yeah, we'll do that. Okay. All right. Well, thank you, Kristine. Okay. All right. So. Okay. All right. Go ahead, Kristine.
There we are. So, howdy, I'm Kristine We're going to be talking about lithium today, mostly because the Willcox Playa has been targeted to be mined for lithium. And most of the information, if not only information, everybody has about this proposed mining activity is coming from Max Power, who is the investment group looking for people to give them money to invest in this potential mine. So let's start talking about lithium. Next slide, Steve. Okay. Wasn't there a slide before this?
Nope, that's it.
Okay. Then I'm confused. Okay, let's see where the Willcox Playa is. And I want you to look also up to the Gila Valley and over to the left at the San Pedro Valley. And what you'll see that is curious is that in the Willcox Playa area, you see all of these green irrigation circles. You don't see that in the Gila Valley or the San Pedro, both of which do have some agricultural activities. But in the Willcox Playa, there's an overwhelming number of green irrigation crop circles where they are pumping groundwater to irrigate all these crops. The Willcox Playa and the basin are very unusual in Arizona because there's so much fresh water. However, the water table is dropping as all of these irrigation pivots are pumping water. Next slide. Okay, I want you to look at the periodic table of the elements. I'm sending you back to high school when we all first learned about this. Now, you'll see lithium in the upper left-hand corner. And I've also put in a pale circle around lithium, sodium, potassium, beryllium, magnesium, calcium. They're all a family. They're all small guys. They're not very massive. And they all tend to hang out together. So where you find beryllium, you're likely to find lithium. Where you find lithium, you're likely to find sodium. And sodium goes over to the blue column and joins with chloride and makes sodium chloride, which is salt. You'll also see in the bottom of this image a cutaway of a battery. And what it shows is that the little electrons shown as green in lithium move from the anode to the cathode, etc. And that's what makes the power in a battery. And that's why with all of the new electric vehicles and usage potential for lithium, it is becoming such an important commodity. Next slide. Okay, let's talk about where we can find lithium. And I'm going to talk about source rocks first. And the source for lithium is volcanic. And I refer to those volcanoes that don't make it all the way up to the top and spew out magma and lava. I call those volcanoes frustrated volcanoes. They don't make it to land surface. So they're stuck underground. And as they very slowly cool, the minerals in that hot magma, they clump together and they form granite. Now, granite can be several different types of granite. The term granite is sort of generic. You can have andesitic granite, for example. This is a picture of Round Top Mountain in West Texas near El Paso. And this was one of my early introductions lithium and beryllium. It was first identified as a beryllium mine site. They mine with a backhoe and with a bulldozer. And then they take the material to a processing facility where they separate the crystals of lithium and beryllium and other constituents out of the frustrated volcano. Now, what you should know about frustrated volcanoes is that they don't make it to land surface, but they sit there for millions of years, and slowly everything around them is eroded. The top is eroded, and then you can see the outline of the original frustrated volcano. Now, there's been a lot of research done on this location. For example, they were looking for, well, we know lithium likes to dissolve in water, so did any of the lithium from this granitic frustrated volcano dissolve in water and then pond and little playas, and would there be concentrated lithium there? And they were surprised to see no. Lithium, as it moves in water, will tend to connect with clay and stick to the clay. And the research has shown that within 2 miles of the original source, if lithium has dissolved in water, it gets absorbed by clay before it moves any further on. Lithium is found in the ocean at around 1 part per million. And the speculation is because the lithium that is eroding and dissolving and moving through the environment, by the time it gets to the ocean, it is absorbed by clay. Next slide. Here is another volcanic source, and that's volcanic ash. And this is, a typical picture of the Chiricahuas south of you guys. Now, the volcanic ash blows out of the top of a volcano. And in our situation, the Turkey Creek caldera in the Chiricahuas, which is 6 miles wide, blew its top, and the volcano collapsed inward. So the caldera is about 6 miles wide. Now, the ash will have different characteristics depending on the temperature of when it fell and how much fell on top. But the Chiricahua ashes have not been measured to contain a great deal of lithium. However, there are other ash falls, some in Australia, some in Nevada, that the ash, and as it ages, it turns into clay. That ash becomes a mineable economic resource for lithium. Next slide. Okay, this is my favorite one. This is in Australia, the current #1 producer of lithium. Now, when you have frustrated volcanoes deep in the earth, the material, like-minded minerals, for example, lithium and beryllium and those others that are close to each other in the periodic table, they are trapped down with the hot body of magma. And they're under a great deal of pressure and a great high temperature. And occasionally they find an escape. They burst up through existing fractures and cracks, looking for getting out of town. And you can see them like as basaltic dikes. But when it's a pegmatite, what that means is it's very rich in specific minerals. And this pegmatite, which is like a huge pegmatite, look at the backhoe in the bottom of the picture. What they're doing in Australia Australia is they're blowing up the rock, they're digging it up, they're shipping it to various locations. There's a couple of facilities that process this in San Antonio, in Corpus Christi, and they're building one in Saudi Arabia. All of them are dependent on the infrastructure, typically by boat, to be shipped to a facility. And for example, in Texas, when it gets to Texas, it's taken by rail to San Antonio. And the lithium is extracted. Now I want to show you my pegmatite. And
Yeah.
I don't know if
They're not going to be able to see it in the room, I don't think. You want me to try? I think the folks online will be able to see it. She's holding up a
Okay.
crystal, sorry.
Yeah, so this is a very large crystal, about 4 inches across, and it's very beautiful. And somebody early on in the chat said, should you be touching that? And I will say, yes, of course. This is a crystal whose major constituent is beryllium, but there's also lithium in this crystal. This crystal was mined in South Africa, and it was shipped to my client in Ohio, who would grind it up, except for the pieces he gave me because he knew I liked them. They would grind it up and make aerospace metals out of this, because lithium is very lightweight and small pieces of it will float on water. And they use it, for example, in missile nose cones and aerospace features, and also, if you have the money, a very lightweight 10-speed bicycle frame. So for those that can see, this is my crystal. You can see the light shining off of it, and it is a typical pegmatite. Next slide.
Kristine, I'm just going to mention the type of mining that's being done here in Australia with this pegmatite. Would that be kind of analogous to some of the open pit mines we see around Bisbee, the Copper Queen, and some of the other ones we see around Arizona for copper primarily?
Oh, yes. And the copper mines have a similar history with the saturated fluids being tracked down in the magma body, trying to escape and then finding its way up to land surface, carrying copper and gold and silver with it, and depositing those minerals in the host rock. So this is very similar, and probably exact, except for the minerals, as what you see in Bisbee and Globe and Patagonia and other open pit mines.
Okay, thank you.
Okay, I just dropped my water bottle. Okay, now we're going to talk about, because I said earlier that lithium, you know, it is a salt, and it likes to dissolve in water. And when given the opportunity, it will dissolve in water. And then you find it in layers of salt beds, deep salt beds. And so the image you see to the left, which is the best I could find, shows the major salt deposits in the United States. Now, we know that, for example, Morton Salt is mining salt near Luke Air Force Base in Phoenix. But that salt bed isn't big enough to show up on our map. The salt we have in Willcox isn't big enough to show up on the map. The one salt bed you see in northeastern Arizona, you may remember about 20 years ago, there was a big effort by a number of investors to collect money to mine the potassium out of that salt bed. And that was around for a few years with interesting publicity and propaganda. Invest in our company, we're going to make millions of dollars taking potassium out of the salt bed. And then it went away. But the most humongous salt bed is Texas. And what's interesting about salt, it can be thousands of feet below land surface. There's thousands of feet of salt beneath Tucson and Phoenix, which means the deeper you drill, the more salty is the groundwater. And the deeper you drill, for example, at Luke Air Force Base, the more you bump into salt, and you can pump it out of the salt bed. The way they do it at Morton Salt is they inject fresh water into the salt. The salt is dissolved, and then they pump the salty brine back up to land surface and put it in ponds so that the water evaporates. And then they collect the salt. And I spoke to the manager of the facility. They did a chemical analysis of their salt, and it's 99% sodium chloride, NaCl, no lithium in that salt. However, you look north of that, there's the Great Salt Lake. There's a lot of lithium in that salt body. But look at Texas again. There is so much salt in Texas and Louisiana and in that Gulf area. So much salt. And salt is plastic, meaning it wants to move around. And it's not as heavy or dense as the rocks above it. So it wants to push up to land surface. And where you see the dark blue image on the deep salt beds is where that salt has relocated itself, some to the point of actually reaching land surface. For example, in Louisiana, there's locations where there's salt at land surface that has moved up thousands of feet and become exposed on the land surface. Why this is important is that when those salt bodies move up, they move up in a form that is sort of like a lava lamp, if you remember those from the 60s. And oil migrates and is trapped underneath that salt. And that's where they drill for oil. Now, in Texas and Louisiana, and also in the Marcellus Play, which is up near Ohio and Pennsylvania, for every barrel of oil you produce, you will typically bring at least 8 barrels of salt to the land surface. And so that's why it's called produced water. It's produced during oil production. Now, the one you see up in the Marcellus, that's what made fracking so famous, because Pennsylvania has no environmental rules addressing oil production. So when they would bring up the oil and the produced water, they would just throw that salty water, sometimes 10, 100 times saltier than the ocean, and they would throw that into the streams and rivers and cause horrendous environmental problems. Whereas in Texas and Louisiana, and also Ohio, where there's some production, they have very good environmental rules about what to do with produced water. And next slide. And this is where it gets interesting. I was lucky the past couple of years to be on a research project with the University of Texas, the Bureau of Economic Geology. And our research was to sample every one of those little black dots, which represent you'll notice, for example, and you can see the outline of the state of Texas and the border with Mexico. You can see up on the top the Anadarko Basin. There's a couple of reported lithium concentrations over 200 parts per million or milligrams per liter, and some at 500 milligrams per liter. Now, the problem with that is that this was historic data reported by the USGS. We went back and sampled those exact same wells, and we didn't get anything over 40 milligrams per liter. So I think I don't know, maybe there was an earlier analytical method that didn't work or something. But none of our results were above 40, except for the Smackover Play, which is sort of in the middle, and it straddles Texas and Louisiana. And they are already mining borate and bromide out of the produced water there, and they're beginning to develop methods to extract the lithium from the produced water. Now, I had mentioned the Marcellus play in Pennsylvania, and let's look at that chart in the lower right-hand corner. The bottom is the concentration of lithium, and the side is the location in terms of probability of there being lithium at these concentrations. And they did the same research we did, except for Pennsylvania. And they divided up their oil play into the north, northeast, and the southwest, because they wanted to see where they could get the best lithium. And you could see that the northeast, they had lithium concentrations up to 400 and 500 milligrams per liter. Now, what we also discovered during our, I think it was about 3 years of research, you cannot economically extract lithium from produced water or any water unless the concentration is greater than 40 milligrams per liter. Anything less than 40 milligrams per liter, it's more expensive to pull that lithium out of the water than you could ever get paid for offering it. The other thing that we discovered in Texas, because I did a great deal of research on lithium back then, the whole state of Texas has elevated lithium in all of its groundwater. But when I say elevated, their municipal wells really don't have anything over 10 milligrams per liter. But that's lithium in the drinking water. And the Texas Department of Health was worried. We've got all this high levels of lithium. How is it impacting the health of our population? And they did a statistical analysis, and they found locations with high lithium in the municipal drinking water, people were relatively peaceful and happy. But locations with low lithium, there were high percentages of suicide and criminality. Nobody believed it when they published that. So Japan duplicated the research, and they found the same thing. England duplicated the research, and they found the same thing. High lithium, happy people. Low lithium, crime. Now, this corresponds with the fact that lithium is often used in psychological medication. Next slide.
Kristine, can I just ask you, clarify on that too? Because up to a certain, that's probably only true that the beneficial effects in terms of overall level of happiness and contentment is probably only good up to a certain percent. Anything in a higher concentration potentially could be toxic. Is that true, or with lithium?
Well, when you talk about toxicity, yes, it could be. The worst evidence of toxicity is with citrus plants. It will kill an orange tree. But with people, they haven't really had any people drink high enough lithium to cause toxicity.
So in other words,
At least not with.
if there's a high concentration of lithium, just like with any salt, it will damage plants, particularly the citrus, an
And
example.
also, if you have high concentrations that you're taking it medically, it will damage your kidneys,
Okay,
okay?
all right,
So,
thank you. Next
now,
slide.
peaceful, easy, yes.
Yeah, a peaceful, easy decline, yes.
Yeah, with low lithium. Now, the next location where we want to talk about is lithium that is found in the salt, similar to the produced water. When you drill an oil well, you'll hit some salt, you'll get some produced water. In the Salton Sea, they have been using some of the geothermal energy from the deep water for energy development. And the water that comes in from the deep salt, they've measured as containing up to 400 milligrams per liter of lithium. And so they are going forward with determining how best to extract that lithium from the deep water. Now let me explain something about geothermal power. There's a number of locations, like Yellowstone and the Salton Sea, where deep magma heat deep in the earth escapes up to land surface and makes these steam stuff and hot beds of water. If you go to Safford, there are a number of exploratory boreholes that wildcatters had gone across Arizona looking for oil. And they drilled through the Safford Valley, and they did not hit oil. You're not going to get much oil in Arizona. The entire state production of oil for an entire year is less than 1 day production of one well in Texas. So oil is not here. But those wildcatters put in deep boreholes, and then they just left. They left those boreholes open. And they're all seeping salt water to the land surface. And some of that is under artesian pressure, which means the overlying rocks are pushing down hard enough that the salt water is bursting up to land surface, contaminating agricultural fields, but also offering business opportunities who want to open up spas in Safford. The Bureau of Reclamation has one of those wells that they manage, and you can go there and play in the salt water. So that's the Salton Sea. That's the next big lithium production here in the United States.
And at what depth is that hot water being pumped up from usually?
Oh, I used to know a couple thousand feet.
Easy, yeah. Yeah, I think I'd heard in part of the Salton Sea, some of it's as much as 10,000 feet.
Yeah, that would make sense.
They call this area Hell's Kitchen around the Salton Sea. And they have a plan to extract, they're using it for geothermal power, but they're also going to extract lithium at the same time. So That's a big
They're
project.
also using geothermal power
Right,
in Iceland.
yes,
And that's because their deep magma bodies are not forming frustrated volcanoes. They're actually making their way to the land surface and making lava flows. Next slide. So let's start talking about Willcox and if there really is lithium in our valley. Now, most of my information I have from the July 16th, 2018 extensive report published by the Arizona Department of Water Resources, where they built a groundwater flow model of the Willcox Basin. This was before Riverview started pumping as much water as they're pumping now. Now you look at this map, and the colors, the contours, are the depth to bedrock. The purple line is the extent of the groundwater model, and the black line is the watershed boundary. Always remember this, a watershed boundary is not the same as a groundwater basin. And this kind of shows it pretty well. A watershed boundary is based on topography and where the mountains are. A groundwater basin is where there's, in our case, an alluvial basin that's porous and it holds water. Now, when you look at the topography of the bottom of our basin, we have a couple of really deep 5,000, 4,000, 4,000 feet depth to the bedrock. But we know that, for example, Riverview has drilled about 20 wells more than 2,000 feet deep. Now, when you pump from the bottom of the aquifer, you will have water for quite a while. But the people, your neighbors, the water table will drop and they won't have water for as long as those deep wells are producing. And Steve had pulled together some geologic logs for me from the ADWR Wells 55 database, which is an excellent source of geologic information and where you can find geologic logs that have been posted to the database since 1980. And a number of those logs went to the bottom, and the person who was not a geologist identified that bottom layer as tuft, T-U-F-T. That is not a geologic term. Remember, the volcanic ash was tuff, T-U-F-F. Tuft is like a bunch of grass or something. But that pointed out to me that the person that was reporting the geology was not a geologist. And I think that's a problem in Arizona because ADWR does not require the geologic reporting for well drilling to be done by geologists. So let's go to the next slide. Well, wait, go back. The reason for that model was to predict how deep the drawdown, how much the water table will drop over 100 years. And the groundwater model said as much as 917 feet. And that was before Riverview. We've already got more drawdown throughout the valley than what they had Next slide.
Yeah, before I go on, I'll just mention too, Kristine, that model that was done, as you said, was published in 2018, was actually based on 2014 data, so it's even worse. Potentially, if they updated it today, it'd be potentially significantly worse than the drawdown than what they stay there of the 917 feet.
Yeah, good catch,
Yeah,
good catch.
thanks.
Yes, whenever you publish something, the data you're publishing was collected and analyzed before the publication date. So as Steve said, the data for this particular numerical model that predicted 917 feet of drawdown near the Kansas settlement was based on data from 2014.
Yep.
10 years ago. Okay. This is also from ADWR. If you want some good reading to understand your hydrology and geology, download that report from the internet. Now, what we're looking at, the arrows are showing where groundwater is moving. Those little circles in black are where the drawdown has occurred as of 2014. You can still see the Willcox Playa. You can see the Chiricahua Mountains. You can see the Galileos. And those are all volcanic rocks or frustrated volcanic rocks. Now, the report from Max Power talks about the Three Sisters. And the Three Sisters are those small volcanic rocks identified where there's actually 4 little blobs of purple. Now, what's interesting, when I was reading the Max Power information, they were saying that the Three Sisters were formed by ash that came from Apache Leap volcanics, which is to the north, and the Chiricahuas, the ash came from the south. Know that the ash from the Chiricahuas have been found north of Safford, west of Tucson, and also all the way over to New Mexico. So volcanic ash, if you can remember a couple of years ago when the volcanoes exploded in Iceland, and it made a lot of the airplanes be grounded in Europe because the ash was clogging the airplane engines. And also before that, the Mount St. Helens up in the northwest, the ash went all the way, I think, I don't know, Nebraska. Ash goes really far. Now, the cool thing about ash is you can look at the specific geochemistry and you can tell which exact volcano it came from, because every volcano, every frustrated volcano has unique geochemistry, a unique combinations of elements. Next slide. Okay, this is the most important slide in my talk. Okay? Look at the graph on the top right. ADEQ and ADWR sampled water quality, and each one of those orange spots is a well in the Willcox area. And they measured how much TDS, total dissolved solids, which means how many dissolved salts are in this water. Like the ocean has 20,000 TDS measured in milligrams per liter or parts per million. Okay? there was a direct correlation between well depth and concentration of salt. If you look on the left-hand side of the graph, you'll see that from 0 to a little bit over 100 feet below land surface, you could have some pretty high salt. Now, know that the federal EPA says you shouldn't really have anything over 500 TDS in drinking water because that will damage your kidneys. But more importantly, it tastes too salty and nobody drinks it. Even if you add anything, you cannot drink it. It's too salty. So the shallow groundwater near the playa, not deeper than about 100 to 150 feet, might have salt that might contain lithium up to about almost 1,200 parts per million or milligrams per liter. And we don't know because nobody has measured or told us what portion of that might be lithium. Now, this is what makes the Willcox Playa and Willcox Basin so very unique in Arizona. And this is why you see so many irrigation circles all the way up to bumping into the playa. Because you have fresh water, and the deeper you go, the water is still very fresh. That's opposite of Tucson, that's opposite of Phoenix, and it's opposite of most locations in the West. Everywhere else, the geologic time, there was salt beds laid down before there were aquifers laid down. And this is why Riverview came to Willcox. Also because there were no rules that would restrict them. But it meant that deeper they went, they would always have very fresh water. Now, look at Lake Cochise. It started about 14,000 years ago, which isn't very long ago. And the reason it formed is that north of the valley, there was some earthquake or maybe a lava flow or something that interfered with the flow of the river that used to flow through the valley. The river that would deliver fresh water and fill up the aquifer. So the river was dammed and a lake formed. But the climate changed and it became more arid. And the lake began to evaporate to the point where it evaporated almost completely up to almost 10,000 years ago. So there's been salt on top since 8,900 years ago.
And Kristine, and salts would continue to accumulate on the lake, on the Willcox Playa, when water drains to the playa and sits there, it typically just evaporates. So that salt would continue to accumulate, but it's all at the surface. It's not reaching depths, anything deep.
Correct. It's at the surface.